Hello everyone. In the last tutorial, I have discussed about how to draw shear force and bending moment diagram for a simply supported beam subjected to point load only. Now in this tutorial, I'll tell you how to draw shear force and bending moment diagram for a simply supported beam subjected to point load as well as uniformly distributed load. So this is the example of simply supported beam which carries point load as well as uniformly distributed load. So this is the first point load is a 10 kilonewton which is at a distance of 1 meter from the left hand side, and second is 20 kilonewton which is at a distance of 5 meter from the left hand side, and uniformly distributed load is acting 5 kilonewton per meter over a distance of 4 meter. The total span of the beam is 6 meter. Now first label the diagram. This is point A, this is point B, this is C and D. This is reaction RA, this is reaction RB. So first calculate the reaction RA and RB. So to calculate the reaction RA and RB, apply the equilibrium condition. The first equilibrium condition is sum of all horizontal forces are 0, then sum of all vertical forces are 0, and sum of all movements about any point are 0. The first equilibrium condition will not apply because there is no horizontal force in this diagram. So to apply second and third equilibrium condition, we have to consider upward forces as a positive and downward forces as negative, clockwise movements as a positive and anti-clockwise movement as negative. So sum of all vertical forces are 0. So in this diagram, RA is acting vertically upward, so it is positive. Next is 10 kilonewton is acting vertically downward. Next is 5 kilonewton per meter acting on a distance of 4 meter. So total becomes 20. Next point load is 20 kilonewton acting vertically downward. Next one is RB is acting vertically upward. So sum of all these forces should be 0. So from this, RA plus RB comes out as 50. This is equation number 1. Now last equilibrium condition is sum of all the moments about any point are 0. So by taking movement about point A, so we have to consider A as center. Now first force is 10 kilonewton which is at a distance of 1 meter from point A, and this tend to rotate the beam in clockwise direction, so this is positive. Next is UDL uniformly distributed load is 5 kilonewton per meter acting on 4 meter. So this is the load, and distance of its CG from point A is 3 meter. So CG lies at half of the total distance. This is 4 meter, half is 2 meter, 2 meter plus 1 meter. This becomes 3 meter, and it's clockwise direction. And next one is 20 kilonewton is at a distance of 5 meter. Last one is RB, tend to rotate the beam in anti-clockwise direction, and RB is at a distance of 6 meter. So sum of all these moments should be 0. So RB is equal to 170 by 6. So it comes out as 28.33 kilonewton. Put the value of RB in equation number 1. So RA comes out as 21.67 kilonewton. So RA is 21.67 and RB is 28.33 kilonewton. Now plot shear force and bending moment diagram by left and right hand method. So first one is shear force diagram. So in left and right hand method, we have to take each point 2 times by taking just left and just right and sum up all leftward forces. So first one is shear force on just left of point A. There is no shear force on just left of point A, so it is 0. Next one is shear force on just right of point A. So place your finger on just right and sum up all leftward forces. So leftward force is 21.67 kilonewton, which is acting vertically upward, so positive. The next point is point C. So shear force on just left of point C. So place your finger just left and sum up leftward forces. Again one force is there, 21.67 kilonewton, acting vertically upward. Next one is shear force on just right of point C. So place your finger just right and sum up all leftward forces. So 21.67 minus 10. So this becomes 11.67 kilonewton. Next point is point D. So shear force on just left of point D. So place your finger just left of point D and sum up all leftward forces. So first one is 21.67 upward, 10 is downward, and 5 kilonewton per meter acting on 4 meter. This is also downward. So net becomes 8.33 minus kilonewton. Now shear force on just right of point D. Place your finger just right and sum up all leftward forces. So first one is 21.67 upward, 10 downward, UDL uniformly distributed load is downward, and 20 kilonewton is downward. So net becomes minus 28.33 kilonewton. Now shear force on just left of point B. Again the shear force remains same, 28.33 kilonewton. Now shear force on just right of point B. Place your finger on just right of point B and sum up all leftward forces. So this becomes minus 28.33 and plus 28.33, so net becomes 0. Now I have to plot all these points on this reference line. So first is point A got 0, second value of point A is 21.67, then C has got 21.67 and 11.67, then D has got minus 8.33, then minus 28.33, and B minus 28.33 and 0. Now I join all these points with a straight line. By joining these points with a straight line, we got our shear force diagram. So this is our shear force diagram for this simply supported beam which carries 2-point load and UDL also. Now next one is bending moment diagram. Now to draw bending moment diagram, take each point one time. and calculate the moment due to leftward forces. So bending moment, first point is point A, bending moment about point A. So on the left side of point A there is no force, so bending moment is 0. Next is bending moment about point C. So on the left side of point C there is one force, it is 21.67, which is at a distance of 1 meter from point A. Tend to rotate the beam in clockwise direction. So this is 21.67 kilonewton meter. Now next one is point D, bending moment about point D. So on the left side of point D, first force is 21.67, which is at a distance of 5 meter, and it tend to rotate the beam in clockwise direction. Next is 10 kilonewton. 10 kilonewton is at a distance of 4 meter from point D. It tend to rotate the beam in anti-clockwise direction. Next one is UDL. UDL is 5 kilonewton per meter acting on 4 meter, and distance of CG from point D is 2 meter. So this is negative. It tend to rotate the beam in anti-clockwise direction. So the net becomes 28.35 kilonewton meter. Now last point is point B. So bending moment about point B. So on the left side of point B, first force is 21.67, which is at a distance of 6 meter. You tend to rotate the beam in clockwise direction. Next is 10 kilonewton, which is at a distance of 5 meter. You tend to rotate the beam in anti-clockwise direction. Next one is 5 kilonewton per meter acting on 4 meter, and its CG lies at 3 meter from point B. You tend to rotate the beam in anti-clockwise direction. Next one is 20 kilonewton, which is at a distance of 1 meter. You tend to rotate the beam in anti-clockwise direction. So net becomes 0. Now plot all these points on this reference line A. Now A has got value 0, C has got 21.67, D has got 28.35, and D has got 0. Now join A to C with the straight line, then C to D is with curved line. Wherever there is UDL, we have to join that point with curved line, then join D to B with the straight line. Now this is the bending moment diagram for a simply supported beam which carries 2-point loads as well as UDL. Thank you for watching the video. Stay home and save lives. Thank you very much.